Okay, now we've seen the point function, and now let's combine that with the second function that I would call one of the most important ones, and that is Nearpoint. So let's say we have a grid, and we've seen that we can, let's say from a second sphere that we turn into a polygon, maybe not that many, we can steal the color. Let's create random colors with the point function by just saying we override the color of the point on the grid with an attribute from the second input. Which attribute? Well, a color, and from which point, let's say point 12, I don't know. And then every point on the grid will get the same color as the point 12 from the second input, which is somewhere here, it doesn't matter. Or maybe let's steal from point 38, so everything should be some kind of bluish. Now that's interesting and good that we can do that. And what we also saw is we could replace the point number with the current point number of the current point, which is kind of weird in this case, because as you can see, we don't have enough points actually on the sphere. The sphere only has 42 points. The grid has 100 points. And after that, as you can see, if we try to read out an attribute of a point that doesn't exist, we get 0, of course. So this isn't really helpful here. But now comes a new thing, and that is, instead of putting in some specific number, we can actually find the nearest point relative to us. And let's use an internal variable for this, because it uses a point number, so that's an integer. Now we can use our function here in a separate line, and the function is called Nearpoint. And as you can see, it basically has, in its simplest form, only 2 inputs. Let's quickly open the help as usual. There it is. And as you can see, the nearpoint is a function that uses an input and a point. So here pt, what could that mean? Well, very important, you don't put here a point number in, which is not obvious from the name of the input. But here, up here, you can see that the input is a vector. And that means the second input is probably a position in space, which makes sense because if you try to find the nearest point on another geometry, putting in a position that you search from makes a lot of sense. And the second thing we can learn from this is what kind of data it returns, and that is int. So it actually is explained down here. It returns the number of the closest point on the geometry. So the number of the closest point means the point number. And this is why the return is integer. And this is why I prepared here the internal variable to be an integer as well. So how did this work again? We use an input, which of course is 1 because we want to read in the second input. And we want to read from a certain position. Which position would make sense here? Well, our position of the current point, which of course lives in v at p. So let's see what happens. And this happens. And it makes a bit more sense to understand this by merging the two things, the sphere and the grid. And then maybe I should move the sphere around a little bit so that you can see what's happening. And every point on the grid now looks for the closest point on the sphere and steals what? In the next line, it steals the color from that point. And this looks like this. When you move the sphere around, every point steals its color from the closest point it finds. Let's increase the number of subdivisions a little bit. So this should look familiar to you because this is basically the behavior of the attribute transfer node. And this is actually what we just did in a way. So attribute transfer kind of worked the same. As you can see here, we basically now copied the attribute transfer. And this is because the attribute transfer by default uses a max sample count of 1. So it looks for exactly 1 point on the sphere and steals any attribute actually. We only steal the color. So in this regards, we just created our own attribute transfer node. Again, why would you use that? Well, mainly because you can now use that inside of your own functions and you can extend it by something. For example, we could again say, okay, we only want this to happen in a certain area by painting a mask attribute, something like this, I don't know. And then we can say only override the color with the color from the closest point if the mask attribute is higher than 0.5, for example. And then we can add in conditions. And there you go. We built our own attribute transfer, but with a mask function on top. Of course, we will use Nearpoint in combination with point for other things, but so far you can see the two kind of work very well together and allows you to steal any kind of attribute from another geometry based on what the closest point is. So I hope this is helpful so far. Thanks very much. See you later. Cheers.